Welcome to homework.
Factors that could help Bella in reducing the size of the margin of error and so making the confidence interval narrower for a mean with no standard deviation would be having a larger sample size, because increasing this will reduce the standard error and consequently decrease the margin of error. As the sample size grows, the estimate of the mean becomes more precise. She could lower the confidence interval. The confidence level. So choosing a lower level like a 90% instead of 95% would result in a narrower interval. But a lower confidence level also means there's a higher chance of the interval not capturing the true population mean. And smaller variability in the data. If the data points are more tightly clustered around the mean, the standard deviation will be smaller, resulting in a smaller standard error and narrower confidence interval. The factor that could produce a new confidence interval with a larger width or a larger margin of error based on the same data set would be a lower sample size. With a smaller sample size, the standard error is going to increase, leading to a larger margin of error and a wider confidence interval. A smaller sample size means less information about the population, leading to a less precise estimate of the mean. So now let's compute the 95% confidence interval for the proportion of firms that have implemented new software. We'll use p-hat and the sample size to calculate this confidence interval. So we know that the sample size is 30. The number of firms that implemented the new software was 8. And so p-hat's going to be 8 out of 30, which is about 0.2667. And now we calculate the confidence interval using the formula p-hat plus or minus the critical z times the square root of p-hat times 1 minus p-hat over the sample size. Z is the critical value for the desired confidence level, and for a 95% confidence level, it's 1.96. So we've got p-hat plus or minus 1.96 times the square root of p-hat times 1 minus p-hat over the sample size. The lower boundary, I'll go to 4 places. So that would be found by subtracting. And that is 0.1084, and the upper boundary from adding 0.4250. And now we'll calculate the sample size required for a 95% confidence interval with a width of only 0.025. That's a margin of error of 0.025 on each side. And so we're going to use the formula n equals the critical z times the square root of p-hat times 1 minus p-hat over the margin of error, the whole thing squared. Now, critical z again is 1.96. P-hat is 0.2667. And our margin of error is going to be 0.025 on each side. And we'll square this. And then we'll round up to the nearest person. And that's about 1,203 people. Actually, I'm going to change this last one. I think we should be dividing by our desired level of 0.05, not dividing that by 2. I think that'll be incorporated. So I think our sample size should actually be 301. Hope that helps. Good luck.